Hi to everyone. In this video, I'm just going to discuss about us how to do the program to implement stack operations. Okay. So as usual, at first we are just going to include the comment section, that is a documentation section, in which I have written here as this is a program to illustrate the stack operations. Stack operations that you know very well, we are going to do the push and pop operations, right? So then, as usual, we can include the header file. That's why I have included the header file stdio.h and conio.h. These are all the necessary header files for the implementing this program. That's why I have included this one. Then, as usual, I'm starting with the main function. So void main. Then open curly braces. Then what should I do it here means whenever if I'm going to do the stack operations means it's very important to define the stack as first. Okay, so how can we implement the stack means we can implement the stack in two ways. One is by using the array representations, or else we may design stack using linked list concept. But here I'm just using the array concept. Okay, so here I have named my array as a stack itself. So that's why the data type given here is int, because I'm just going to store the integer type of data in my stack. Okay, so int stack of 50. Actually, the array size is 50. Okay, and the name of the array given here is stack. So whenever if I'm going to make use of this stack means definitely there must be a pointer named as a top, because the insertion and deletions, that is the push operations and the pop operations which will happen in one end called a top. Okay, so that's why here I have declared one more variable as a top, and I'm just initializing the variable top with the value 0. Why I am setting top is equal to 0 means because when the array is empty means then the top value would be null only. That's why here I am setting top is equal to 0. And then here I am setting the maximum size for my stack as 5. It's not mandatory. You may take 50 itself as the maximum size of the stack, but for my convenience here I am setting one more variable. I have declared one more variable as max to define the maximum size of the stack. And here I am just assigning, that is initializing that maximum variable as 5. So it means I will be able to store only 5 elements in my stack. And n, and it's a temporary variable. For getting the choices I'm using the variable n, and I is a counter variable. Okay, and next one is the item. What is mean by item here means whenever if you are defining the stack here means for example, whenever if you are going to define the stack here means you are just going to push the item, and you are going to push the item, and you are going to pop out the item. Okay, so that is the one, that is a data that you are pushing on to the stack, and if you are going to pop it out from the stack, the data which will be called as an item. Okay, so what I am just going to do it here means here I am going to declare the data type for my item as int, because here I am just storing the integer type of data only. Okay, that's why int item. Then as usual CLR is here. Next what I'm doing here is I'm just prompting the user as stack operations. That's why here print of stack operations. Okay, so then I'm just going to give the choices to the user. Okay, so what are the choices I'm going to give it to the user means I'm just going to prompt the user as if the user is typing 1 means then the push operations will be carried on. If the user is typing 2 means pop operations will be carried on, and 3 display, and for 4 it's an exit. Okay, so these are all the choices that I'm going to give it to the users. In order to implement this one, I should get that choices from the user, right? So for such a purpose I'm just going to make use of my temporary variable n. That's why scanf for percentage d ampersand n. Okay, and next one thing, as I said earlier, among the 4 choices, a user can select any one of the choices. What are the 4 choices? 1 is for push, and 2 is for pop, and 3 is for display, and 4 is for exit, right? So, in order to create such type of a menu-driven concept, I'm just going to make use of the switch statement here. I can make use of the switch statement, or else I can make use of if else if ladder. But here I'm using the switch statement because if I'm using the else if ladder means there will be more number of open curly braces and closing curly braces. Those braces can be avoided while making use of the switch statement, and it would be very easy for the programmer to debug the coding. That's why here I have selected the switch statement, right? So here I have written switch of n, open curly braces, and here I have defined the case as case 1 and case 2 and then case 3. In the case 1, I am just implementing the push operations, and in the case 2, I am implementing the pop operations, and in the case 3, we are just displaying the content of the stack. Okay. So this you know very well, push operations, it's nothing but we are just going to insert an item into the stack. So whenever if I'm going to insert the item onto the stack means by that time it's very important to check for the conditions whether the top is equal to the maximum size of the stack. Okay, why I'm going to say this one means why, what's the necessity for checking the maximum size of my stack here is you just consider this stack in which I'm just going to have 3 only. Okay, so it means I will be able to store 3 items only. Okay, you just have an assumption as I'm having 2 here and I'm having 3, I'm having 4 here. Okay, so in such a cases a top which will pointing to this one. Okay, so even after storing the elements in the spaces allocated here, if I am trying to push one more item, for example 5 onto the stack means there is no space here to store this value 5. In such a cases, overflow will occur. This you know very well. Just have an assumption as you are having the bucket and one tap is there. Just have an assumption one tap is there which is pouring the water. You are getting the water from the tap and that water is collected into the bucket here means once a bucket is filled means automatically water will overflow out of the bucket. Because there is no space in the bucket to hold the water. That space is already filled, right? In the same way, once if the maximum size of the stack is reached, means by the time if the user is trying to push an item onto the stack, means overflow will occur. So in order to check for the condition of overflow, we have to check whether the top value is equal to maximum of your stack. That's why here, before doing the push operations, here I am checking for the condition if top is equal to max or not. If it is equal to maximum means, then I am just going to prompt the user as stack reach the maximum limit. Okay. Else, in case if this condition is failed means, then I should increment the top value at first. So I am just going to increment the top value as first here means, because here I have given the condition as a top is equal to 0. You should understand one thing very well. Here we have implemented the stack operations by means of an array only. Once if we are taking the array, we will be able to store the items in the array right from the index 0 to n minus 1. But here, since we are implementing the concept of stack using the array concept, if the top is equal to 0 means, then we are just going to conclude that stack is empty. That's why here at first I am going to increment the value of top as first. Why I am not at all starting the value? You may ask me one question as why I haven't stored the element in stack of 0 means, according to the stack concept, if the top value is equal to 0 means, then the stack is empty. Okay, that's why here I have started the stack pointer with the value 1. Okay, that's why here I have incremented the top value. So top plus plus means now the top value is equal to 1. Okay, so then we are giving the user information as printf, enter the item to be pushed. Accordingly, we are getting the input from the user as scanf percentage %d ampersand item. So we got the input from the user. Then the next thing is to push that item onto the stack, right? So that's why here I am setting stack of top is equal to item. You just consider here before pushing an item onto the stack means top is equal to 0. After executing the statement top plus plus means top is equal to 1. Top is equal to 1. If I am just going to say stack of top is equal to item means, I'm just going to have the statement as stack of 1 is equal to item. This is for the first time when we are pushing. Okay. So in such a cases, whatever the item that you are giving, that will get stored in stack of 1. Okay. So after pushing the item, you can give the break statement. So this very well, break is used to make your program control to comes out of the switch statement here. Okay. So next one thing, since we have implemented the push operations in the case 1, we are going to implement the pop operations in the case 2. So what we have to check it here means while pushing the item onto the stack means we are just going to check for the conditions overflow, but while doing the pop operations in your stack, you have to check for the conditions. What is it when it is called as underflow? What's the necessity for checking that one means you can consider this stack itself. The stack is already filled, three items are there. Just have an assumption as I have popped out all the elements from my stack and now the stack is empty and the top value is equal to 0. By this time, if an user is trying to pop out the element from the stack means you couldn't pop it out. In such a cases, underflow will occur. Okay, so in order to check that condition, we have to check for the condition whether the top is equal to 0 or not. If the top is equal to 0 means it's not suitable for the programmer to pop up the element. That's why here I'm checking for the condition. If top is equal to 0, I'm just printing the messages stack is empty. If this condition is failed means what it means, top value is not at all null. That means at least one element which is present in your stack. In such a cases, you can pop up the element. Okay. So that's why in the else statement, in the else block, I have written the statement as item is equal to stack of top. This you should know very well. Whenever if you are going to push an item onto the stack means at first you should increment the stack pointer, then you have to push the item. While popping out the item from the stack, at first you should retrieve the data from the stack and you should store it in the variable item. Okay, so after popping out, you should set that value as equal to null. For example, just consider here you are having the item here is 1 2 3. Okay, so if I'm going to execute the pop operation means at first the stack of top is equal to what's the value here, top is the pointing to 3. Okay, so stack of top which will have the value 3. I should store this 3 into the variable item. That's why here we are writing item is equal to stack of top. It means we are setting item is equal to 3. So after doing this one only, we are going to decrement the top value. So before this one, top is equal to 3. Okay, so after retrieving the data from the stack, I should set stack of a top is equal to null. So after setting this one, I can decrement the top value. It means I will get top is equal to 2. So after executing this statement, this value will be erased from the my stack. Okay, so after popping out, the top value will be equal to 2. It means the stack pointer top is equal to 2. Fortunately, the item in this position is also 2. Don't confuse the stack pointer with the item. Item is the data, and stack pointer top, it's nothing but the pointer which is pointing to the topmost element in your stack. Okay, so here we are, as I said earlier, we are decrementing the top, then we are printing the information as the item percentage D is popped out from stack, and then we are printing that item. Then we are breaking using the break statement. Okay, so the next one is display operations. This you know very well. What I am just doing here is I am just going to print the content of the stack. That means I am just going to print the elements of the stack. For printing that pen, here I am using the for loop for I is equal to top, I greater than or equal to I greater than 0, I decrement. Why I haven't used I greater than or equal to 0 here means because when the top value is equal to 0 means the stack will be empty. That's why here I haven't used the condition I greater than or equal to 0. And one more thing, why I'm using the reverse loop here means instead of making use of the forward loop, why I'm using the reverse loop here means because stack which will make use of the concept last in first out, right? Last in first out. Last in first out means whatever the item that we have pushed into the stack as last, that will be retrieved as first. It means first in the while considering this stack, at first we will pop out 4, then we will pop out 3, then we will pop out 2. Okay, so whatever the item that I have pushed in as last, that will be retrieved as first. That's why we are saying stack is using the concept of last in first out. Since the stack is making use of last in first out concept, here I am using the reverse loop. So reverse loop means at first I is equal to top, then the condition given here is I greater than 0, then I decrement. So when I is equal to top means by considering this example, the top value is equal to 3 means I is equal to 3, and check for the condition whether 3 is greater than 0. Yes, of course 3 is greater than 0. That's why enters into the loop and it will print the value stock of I means 4 will be printed. Then new line will be this formatting informations will be printed. Then again the counter variable I will be decremented. Now I is equal to 2 and check for the condition 2 is greater than 0. That's why it will enter into the loop since the condition is true, and it will print a stack of 2. In such a cases 3 will be printed. And next what it will happen here is again the value of I will be decremented after printing this formatting informations, and then now the value of I is equal to 1. Checks for the condition 1 is greater than 0. By that time stack of 1, that means 2 will be printed. Okay, so then this printf will be executed, then the value of I will be decremented. Now I is equal to 0 and checks for the condition failed because the value of I is equal to 0. Okay, so then what is that? Then the program control comes out of the for loop, and the next statement in the case is break. That's why your program control will comes out of this switch case. Okay, and you just notice one thing here. Here I am using the do while loop. What's the purpose of making use of the do while loop here is in order to get the choices from the user again and again until the user is typing the value 4. If the user has typed the value 4 means, then I'm just going to stop the process of getting the choices from the user. That's why here I'm using the do while loop. You may ask me one question as why I'm preferring do while loop instead of while loop means, if I'm using the while loop means at first I have to check for the condition, then only the program control will enters into the loop. But here I would like to make the program statements to be executed. That means I wish to execute some statements without checking the conditions at least for once. Okay, that's why here I have given the statement, I have given the loop structure as a do while loop. Okay, so then as usual I have typed the get ch, then I have closed the curly braces. Okay, I hope that you have understand the concept clearly now. Okay, let's do one thing. I will show you the execution of this program. Yes, stack.c. So whatever the things that we have seen there, all that source code has been written here. Simply I am just going to execute this program now. So I am compiling my program and then running my program. See the output screen here. I'm just going to enter the choice 1 here. It means I'm going to do the push operations. Enter the item to be pushed in. Okay, so there I have first entered 2, right? So I'm just pushing 2 here. Then again I'm doing the push operations. So I'm pushing 3. And then I wish to see the content of my stack, so I'm giving the choice here as 3. See the content here, 2 is in the bottom position and 3 is in the topmost position, just like the stack which will hold the item which is recently pushed in at the topmost place. No, so that is achieved here. Okay, so again I'm going to do the push operations. You just see here I'm entering the choices again and again. This is possible by using the do while loop structure here. Okay, so here I'm pushing the same data for these are the informations which I have shown in that uh, um, demonstration itself. Okay, so now see the display 432. All right, so what's the next I'm just going to push one more item onto this stack, for example 10. It's pushed in, then again I'm doing push operation, I'm giving 20. Okay, then again I'm just going to give the push operations. You just see the information here, stack reached the maximum limit. Why? Because I have given the maximum limit for my stack as 5 only, so I will be able to store only 5 items. Okay, so you just see the display once again here. So what are the items present in the stack? 20, 10, 4, 3, 2. Okay. So next I'm going to call the pop operations. So pop means I'm just going to pop out the element from my stack. Okay. So 20 is popped out. Next I'm calling the display. See this one. 20 is not all present in your stack. Then again I am going to call pop. Then display, yes, 10 is popped out, then 2, 4 is popped out, verify it, yes, then again I'm calling pop 2. Okay, so call the display, yes, 3 is popped out. Now just I am having only one element in my stack as a 2 only, right? So here again I am calling pop 2 is also popped out. See the 3 element is displayed here. Again I am calling the pop operations. By that time the underflow will occur, right? That's why here we are just prompting the user as stack is empty, right? Because when the stack is empty we are not supposed to do the pop operations, right? Then in order to exit from this one we can give the choice 4 and then you can stop the execution, right? I hope that you got a clear idea about us how to do the push and pop operations using the C code. In case if you are having any doubt, kindly post your queries in the comment section. Thank you.